Before we can jump into fully living cells, we need to understand a little bit of chemistry on a smaller scale. So everything is made of matter, and matter is something that takes up space and has mass. So if it weighs something and the gravity of the planet exerts its force on it, and it takes up space, however minuscule that amount of space is, something is considered matter. So here are three terms about matter that we tend to get a little mixed up. So an element is the most pure version of a substance. It can't be broken down by a chemical reaction into any other substance. So for an example, we have hydrogen, that's an element. A molecule consists of two or more atoms held together by bonds. So hydrogen exists as a gas form in H2. This is a molecule. Pretty much any atom bonded to another atom is called a molecule. And then finally we have a compound, and this is going to consist of two or more elements in a fixed ratio. So in my molecule, I just had hydrogen bonded to itself. So in this case, if I have H2O, I have two different elements combined in a fixed ratio of two hydrogens for one oxygen. That's a compound. So every compound is a molecule because H2O is two or more atoms held together by bonds, but not every single molecule is a compound. The semantics of this are a little difficult. I personally don't love to ask this kind of question on a test. However, as an informed scientist, you need to use the right word, and I'm pretty much going to use molecule from here on out because everything is a molecule, not everything is a compound. So here we have our theme of emergent properties again, and remember this happens when we go up that ladder of levels of organization. So when we go from the level of an atom up to the level of a molecule, we are going to see new properties emerge. So sodium, this is one element. Chlorine, this is a different element. Sodium, when it is by itself, is clearly a metal. It is a solid. This guy is cutting this with a knife. Chlorine as an element by itself is a toxic gas. So good thing they've got the stopper because this could cause some serious problems for your respiratory system. But when we put this metal and this toxic gas together into this molecule, which is also a compound, it becomes salt. NaCl is table salt. And this is a crystal, and it is extremely yummy. We put it on our food. We don't normally eat metal or toxic gases, but when we combine these in this ratio, it has a new property. It has new structure, and it's going to result in a different function. So the human body is mostly made up of these four elements: oxygen, carbon, hydrogen, and nitrogen. The vast majority of your body mass is oxygen, and that's because it includes the oxygen that's inside of water. You're mostly water, but most of the mass of water is oxygen because hydrogen weighs a lot less than an oxygen molecule does. Carbon is going to make up all of the backbone and structures of the majority of your organic molecules, and then oxygen, hydrogen, and nitrogen are going to exist on those molecules as well to give them their unique structures and functions. So you do need to know that the vast majority of your body is made up of these four molecules. The rest of these molecules, if you look, combined together, make up about 3.7% of your body mass. Things like calcium, phosphorus, potassium, sodium, chlorine. These are used often in chemical reactions. Sodium and potassium are extremely important for regulating where the water is in your body, which we will get to in osmosis. And then the bottom down here are the trace elements. And trace means tiny. These are found in teeny tiny amounts. So all of these combined make up less than 0.1% of your body mass. But there's some pretty important things down here. Iron, you need iron. Every single molecule of hemoglobin that you have in your blood. You need iodine to make sure that your thyroid is functioning properly. Fluoride is extremely important for tooth health. Zinc is often taken as a supplement when you first get a cold, help kind of shorten your cold. So trace doesn't mean that it's little in importance. A trace element is extremely important. We would not live if we didn't have iron and iodine. But it's only important in small doses because most often these trace elements are not excreted from the body. These are typically recycled, and your body is going to not need to take in very much of it because it kind of hangs on to what it already has.